Hello, and welcome to this presentation on Industry 4.0. This presentation aims to give an overview of Industry 4.0, a rapidly developing form of intelligent manufacturing processes assisted by digital technologies, artificial intelligence, and manufacturing data analytics. Building on this overview, a curriculum has been suggested on Industry 4.0 for students of engineering. The term Industry 4.0 was coined by the government of Germany as part of a strategy to promote advanced technology enabled manufacturing. It was introduced at the Hanover Fair conducted in 2011. Industry 4.0 has been adopted by most leading industrialized economies in the world. The central idea of Industry 4.0 is large-scale optimization of industrial operations across a wide range of parameters, using a bouquet of technologies that form a part of the fourth industrial revolution, a term popularized by Klaus Schwab, founder and executive chairman of the World Economic Forum. The key technologies used in Industry 4.0 include cyber physical systems, industrial Internet of Things, communication networks, closed loop feedback systems, cloud manufacturing, manufacturing analytics, artificial intelligence, virtual reality, augmented reality, digital twins, industrial robotics, and additive manufacturing. These will be explained in the slides that follow. Cyber physical systems are primarily a system of sensors and actuators. The sensors are devices embedded in industrial systems and are used to monitor physical parameters such as temperature, flow, proximity, vibration, pressure, emissions, and sound. Actuators are the mechanical devices that are operated by controllers to take corrective action, leading to optimized processes. The Industrial Internet of Things is the technology that connects the physical systems using cables, wireless communication systems, and the Internet. The IIoT connects the sensors and actuators with the controlling systems such as the PLCs, the SCADA systems, and edge computing environment. The data is processed by controllers, optimized using AI and ML algorithms, and fed back for corrective action to actuators. The facility that is used to store this data and offer controlled access is known as the cloud. Data requiring real-time response is maintained closer to the operation and is referred to as the edge computing environment. Using the cloud environment, engineers located in different parts of the world can collaborate to design and develop advanced industrial products. The cloud environment can be used for analytics and business intelligence. Cloud services can be rented on a scalable basis, enabling small players to avail of cloud services without having to invest in the facility. At the heart of intelligent manufacturing is data analytics. The components of data analytics are descriptive analytics, it explains what is happening, diagnostic analytics, it explains why it is happening, predictive analytics, it tells you what can be expected to happen, and prescriptive analytics tells you what steps should be taken to achieve the desired results. Virtual reality is a simulation of a physical three-dimensional world. Users can interact and navigate through the digital space as though they are physically present in the space and as though it were real. Augmented reality assists manufacturing and maintenance teams by overlaying real-time digital instructions, 3D repair guides, and performance data directly into their physical view of the machinery. A digital twin is a dynamic virtual replica of a physical asset or system. It uses real-time data to simulate, predict, and optimize its performance, and for carrying out experimentation without disturbing the physical system. Digital twins can be created for a component, an asset like an aircraft engine, a system like an assembly line, a process including material acquisition, manufacturing, and supply chain, and a product through its entire life cycle from design to disposal. Industrial robots are widely used in Industry 4.0 to carry out dull, difficult, and dangerous operations known as the 3Ds of automation. Industrial robots are commonly used for robotic welding, assembly line pick and place, packaging and palletizing, inspection and quality control, CNC machining, and material handling and logistics. A collaborative robot or cobot works alongside humans in a shared workspace. It augments human skills by handling repetitive or strenuous tasks, complementing the ability of the human operator to perform complex tasks requiring judgment and dexterity. An example of a cobot is an exoskeleton, a wearable mobile machine powered by a system of electric motors, pneumatics, levers, and hydraulics that enhance the human operator's physical strength, allowing for limb movement with increased strength and endurance. Robots are automated using advanced algorithms. Some commonly used algorithms are object detection, localization and mapping, motion planning and control. Robotic design includes advanced sensors used for automation. Some critically important sensors are force and torque sensors and proximity sensors. Robots perform tasks using grippers and end of arm tooling. Choice of grippers and EOAT is critical to robotic design. Industry 4.0, with its highly enhanced focus on optimization and automation, seemed to leave the human operator out of the reckoning. Industry 5.0 tries to humanize Industry 4.0 centric operations by stressing upon enhanced autonomy, empowering people, customization and flexibility, sustainability and ecological responsibility, human centric and ethical working, and continuous learning. The technologies explained here are used wherever complex machinery and process equipment are deployed on a large scale. Operations need to be optimized by the extensive application of digital technologies, manufacturing analytics, and artificial intelligence. Effectively, every domain of engineering requires a good understanding of Industry 4.0 technologies, though the level of coverage may vary across streams. The key constituents of the proposed Industry 4.0 curriculum will include the following: the fourth industrial revolution, key technologies of Industry 4.0, industrial automation, mechatronics, and robotics, Industry 5.0, artificial intelligence and manufacturing, and Industry 4.0 implementation roadmap. Coverage of the fourth industrial revolution will include drivers of the fourth industrial revolution and combining the digital, physical, and biological worlds. The key technologies of 4.0 to be covered will include cyber physical systems, industrial Internet of Things, artificial intelligence, big data analytics, digital technologies, automation and robotics, blockchain, and virtual reality and augmented reality. The key technologies of Industry 4.0 will also include digital twins, additive manufacturing, control systems used in Industry 4.0, security challenges in control system architecture, operations technology and information technology, cybersecurity for industrial control systems, factors driving the development of Industry 4.0, and lean and agile manufacturing in the digital age. Industrial automation, mechatronics, and robots will include application of industrial robotics, robotic control, robotic sensor technology, end-of-arm tooling, collaborative robots, and emerging trends in industrial robotics. The coverage of Industry 5.0 will include enhanced autonomy, empowering people, customization and flexibility, sustainability and ecological responsibility, human centricity and ethics, and continuous learning. Artificial intelligence in manufacturing will cover data driven decision making and AI in operations, AI driven process optimization, augmented operators, and the use of ERP systems. And finally, Industry 4.0 implementation roadmap will include smart factories from concept to reality, the smart manufacturing journey, the layered structure of a smart factory, and maturity stages of the smart manufacturing journey. We have reached the end of this presentation. I hope it has helped you to gain an understanding of Industry 4.0 and the constituents of the proposed curriculum. Thank you for your attention.